Hello, Algebra 2 students. Welcome back to video lesson number 2 on section 7.4. Now, we left off with example 4 last video, evaluating logarithms. Now, so far we've just been rewriting logarithms, switching between log form and exponential form. Okay, now we're going to use that to evaluate logarithms. In other words, find the numeric value of a logarithm. So to do that, we're going to use what we talked about the last time, how to switch from a log form to exponential form. Right now, we don't know how to evaluate a logarithm in logarithmic form, but we can write it in exponential form and evaluate it that way. Okay, so that's what you're going to do for all these 9 examples here. For example 4, we're going to take it as a logarithm, rewrite it in exponential form, evaluate it as an exponential form, and then put it back to logarithmic form for my answer. So here's what I mean. For this first example A, log base 2 of 16. Okay, so I don't know what it is. So I'm going to set it equal to x. Log base 2 of 16 equals x. I'm trying to solve for x. I want the answer. So now I'm going to rewrite that in exponential form, just like you did in your last video, and you did in your first homework assignment. So 2 to the x equals 16. 2 to the x equals 16. Now, this is one that you should be able to evaluate, okay? And all these should be done without a calculator. All these should be logarithms that you can evaluate in your head. What power of 2 is 16? Okay, now be careful. It's not saying 2 times what is 16, right? The answer is not 8. It's not 2 times 8 is 16. The answer is an exponent. What power of 2 is 16? Well, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16. So there we go. So what does that mean? Go backwards. That means that log base 2 of 16 equals 4, right? My x was 4, so my answer is 4. So that is the answer to that logarithm. Log base 2 of 16 is 4. So one more time, we're going to keep repeating this to help it kind of sink into your head. What we're saying when we're answering a log is saying what power of 2 gives you 16? 2 to the fourth power is 16. Okay, let's do that one again. Or the next example, log base 7 of 49. So once again, I think it's going to be helpful, at least the first few times. Maybe after a while you get the hang of it and you can do this in your head. But the first few times it might be helpful to write it and take it as a log form and switch it to exponential form. So 7 to the x equals 49. All right, what power of 7 gives you 49? Okay, and one more time, be careful. It's not multiplication, right? It's not 7 times 7 is 49. That's a big mistake students make. It's an exponent. 7 to the second power is 49. So the answer is 2. The answer is always the exponent. 7 to the second power is 49. The answer to that logarithm is 2. Next one. Now there's no base here. That's the common log. That means the base is 10. So in exponential form, we want to solve this problem. 10 to the x power is 100,000. Okay. I'm not writing the first form anymore. I'm just jumping right to the exponential form. So I'm saying that equal to x. I'm saying that 10, base 10, to the x power is 100,000. Let's see. What power of 10 is 100,000? Remember, powers of 10 are easy. Just count the zeros. There's 5 zeros. So that number is 10 to the fifth power. So what was my exponent? My exponent is 5. So the answer to the log is the exponent. 10 to the fifth power is 100,000. All right, D. This one's tricky. How do I get a fraction? Well, think about your exponent rules. Let's write it out in exponential form. 3 to the x power is 1/9. All right, think about our rules for exponent. What kind of exponent takes the reciprocal of a number or moves that number to the denominator? Well, let's see. 9, I want to write 9 as the power of 3. 9 is 3 squared, but that 3 squared is in the denominator. What happens when I move it to the numerator? Well, I make the exponent negative, right? That's one of our rules for exponents. 3 to the negative 2 is 1 over 3 squared. So the answer that I want then for my x is negative 2, So we're saying that 3 to the negative 2 is 1/9. And notice something here. Anytime you're taking a reciprocal to go from the base to the answer, the answer to the log will be negative, right? Because 3 to the positive 2 is 9. 3 to the negative 2 then is 1 over 9. So just kind of notice, anytime you're doing reciprocals, your exponent will be negative. Next one, log base 12 of 1. So I want 12 to the x power is 1. Well, as you probably know, anything to the 0 power is 1, right? Another one of our exponent rules. So the log base 12 of 1 is 0. And now let's just pause for a moment. Notice something. That 12 didn't really matter, did it? The log of 1 is always 0, no matter the base. The log of 1 is always 0. And real quick, if you go back to what we did in the first video, think of the graph. What did we say about the graph? We said that the x-intercept is always 1, right? No matter what the base is, it always goes to the point 1, 0, because the log of 1 is always 0, no matter the base. So hopefully these concepts are connecting together for you now. Next one, log base 25 of 5. So 25 to what power is 5? That's kind of challenging. Wait, 5 is smaller than 25. How do I get a power of 25 to write it as 5? Well, let me see. What is 5? Can I write 5 using 25? Well, 5 is the square root of 25, right? And what is square root as an exponent? Again, think of your exponent rules we discussed before. A square root as an exponent is a fraction. So the square root of 25 is the same as 25 to the 1/2. So what does that mean? My answer to that log is 1/2. So another lesson, anytime you're using a radical, your exponent will be a fraction, right? Because fractions, exponents are the same as radicals. So anytime you're doing a radical, your answer will be a fraction. All right, part G. I'm going to pause the video a moment, or actually, I'm not going to pause. You pause the video a moment. I want you to try G, H, and I yourself, and then come back and check with me when you're done. Okay, now we're back. Hopefully you tried those. Let's go through this. Log of 1 over 1,000. Well, that's log base 10. So I want to know 10 to what power is 1 over 1,000? Well, 1,000 is 10 to the third. So it's 1 over 10 to the third, right? But just like we did above, that means we're going to make the exponent negative because it was in the denominator. That's 10 to the negative 3. So the answer to this is log is negative 3. Next one, ln of e to the 8th. Well, this ln means base e. But look at your number also has a base e. So let me just write this out just to be clear. So I'm going to set it equal to x. ln of e to the 8 equals x. Well, this ln means base e. So I'm going to say that e to the x equals e to the 8. E to the x equals e to the 8. So just to be clear, this e is the base there. The exponent is x, and this e to the 8th is your answer. Well, what makes those true? Well, this one's really easy then, right? X is 8, right? E to the 8 is equals e to the 8. So that answer is just 8. That answer is just 8, all right? Because the log was base e, but my number here also had a base e. So what I'm saying is that e to the 8 equals e to the 8. All right, last one, similarly, this one also has a base e. A lot of times we'll see ln with the base e because ln means log base e. So ln of the cube root of e equals x. So I want to write e to the x as the cube root of e. Well, just like I did above, anytime you have a radical, let's write it as a fraction exponent. Since it's cube root, that's going to be e to the 1/3. E to the 1/3. So what is the answer? The answer is 1/3. So one more time, anytime you have a radical on your number inside, or you take the square root like we did above, the answer will be a fraction. Anytime you take the reciprocal, your answer to the log will be negative. Okay, so that's how we evaluate logarithms. This is the sort of the most important thing we'll be doing in this section is evaluating logarithms. Okay, the last two examples, graphing log functions, graphing logarithmic functions. So a reminder, this is what the basic graph of a log function looks like. There's 2 points you need to know in an asymptote. You need to know the point 1, 0, no matter the base, the point is 1, 0, and then whatever the base is, that's the x coordinate when y is 1. So 1, 0, b1, and then you have a vertical asymptote at x equals 0. So using that, why don't you draw for me the graph of log base 3 of x? Log base 3 of x. Well, let's see. It's going to go through 1, 0, like all log functions do. Since the base is 3, that's the x coordinate when y is 1. So it's going to go through 3, 1. And it's going to have a vertical asymptote at 0. So it's going to approach that asymptote. And then it's going to go through that 1, 0 and 3, 1. It's going to increase very, very slowly. Very, very slowly. So there's a vertical asymptote at x equals 0. So the domain, therefore, is 0 to infinity. The range is all real numbers. Okay, now let's practice graphing with transformations. Okay, so same transformations rules we've been doing many, many times. So we're just going to notice both of these log graphs are base 3. So I'm going to take this graph above and do transformations. Okay, here we have x plus 4. What's that going to do? That's a horizontal shift because it's inside the parentheses, inside with the x. That's going to shift it to the left 4 units. Left 4 units. So take your vertical asymptote at x equals 0. I'm going to move it to x equals -4. I'm going to take each of these points, shift them to the left 4. So 1, 0 goes to -3, 0. And 3, 1 goes to -1, 1. And then draw your graph. Again, there's a vertical asymptote is at x equals -4. All right, so that means that the domain of this graph is -4 to infinity because my vertical asymptote moved. My domain is going to shift, and my range is still all real numbers. All right, last one. Negative log base 3 of x plus 6. Notice there's no parentheses here. That's what tells you the 6 is a vertical shift, right? This 4 was horizontal, this 6 was vertical. There's also a negative in front. That's a reflection about the x-axis. So I'm going to reflect the graph about the x-axis. I'm going to shift up 6 units. So let's draw that. So one more time, we'll take this basic graph, log base 3 of x. I'm going to reflect about the x-axis and shift up 6. All right. So 1, 0, the reflection doesn't do anything, but I'm going to add 6. It goes to 1, 6. 3, 1, reflect it to 3, -1. Add 6. It goes to 3, 5. So 3, 1, 2, 3, 4, 5. And then the vertical asymptote doesn't change because there was no horizontal shift. So that's still at 0. Okay, but it was flipped upside down. So now it's going to look like this. There's your graph. Okay, so vertical asymptote is still at x equals 0. So the domain, this graph doesn't change. It's still 0 to infinity. And the range is still all real numbers. Okay, so that is it for our second lesson. So we did 2 things here today. We evaluated logarithms and we practiced graphing log functions. So on your 7.4 homework sheet, on the back is going to be your second assignment. Here's going to be your second assignment here. I want you to do the 6 matching graphs at the top, 65 through 70. Just match the graphs with the equation. All these are log graphs and all the same base. Notice they're all log base 5 of x, just using transformations. All right, and then I want you to evaluate logarithms here. So I want you to do, let me write it down here. So 65 through 70 on the top. And then I want you to do 36 through 43 and 45. So evaluate logarithms. Now, some of these you may need a calculator to do because they're really big numbers. But again, I don't want you to evaluate the log in your calculator. You don't know how to do it yet. I want you to do like we did in the previous slide. Change it from log form to exponential form, and then guess and check the exponential function until you can find an answer that works. Okay. There shouldn't be any decimals. These will all be nice positive or negative whole numbers. Okay. Now, a couple of these, the answers will be negative. Remember, every time you do a reciprocal, the answer is negative. So look at like 41. This number is a fraction less than 1. This number is bigger than 1. That's going to tell you the answer is going to be negative because you have to do the reciprocal. All right. Now, when it says evaluate the logarithms if possible, one more thing real quick. Not all of these answers are possible. Okay. So if you remember back to the log function, the domain of a log is only positive numbers. So what that means is the number inside a log cannot be 0 and cannot be negative. So if you try to do the log of 0 or the log of a negative number, it is not possible. So just write down does not exist or DNE. Okay, so work on your second assignment here and share those with me when you're done. And then there's a review sheet I'll give you to do once you're done with those homework assignments.